Ladies and gentlemen, boys and girls, distinguished guests, fellow life forms of planet Earth, and anybody not from planet Earth. Yes, Shane isn't. We knew that already. Well, I'm not either, so that's why we hit it off so well. Welcome. Sorry, forgive me for walking in front of you. Welcome to this delectable, devastatingly stunning, extragalactic, interplanetary evening of wit and information, but not necessarily in that order. It's my name's Fred Watson, I should tell you that, usually. It is when I'm on Earth, anyway. And it's my pleasure to be it says I'm the stage manager, but anybody who knows me will know that I'm totally incapable of managing anything. Miss Manager, that's right, or a Mr. Manager. Thank you, Robin. So it's my great honour, actually, rather than a pleasure. It's a pleasure and an honour to welcome you to the 1859th edition of Science in the Pub in Coonabarabran. They started in 1753. You didn't know that. They did. So welcome to Science in the Pub. I'm very honoured to be here, as I said. We have a marvellous evening for you. Some extremely erudite and very well-known people sitting behind me and wondering when I'm going to shut up. But before I introduce our host for this evening, it's my pleasure also to introduce to you Maureen Salter, who will welcome us to country. Maureen.
Yama, everyone. Oh, some people know that Yama means hello. So if we could all say Yama together, it would be wonderful, because we'd be all saying a Gamilaroi word, and we would be addressing each other to say hello. Okay? Yama. That's lovely, thank you. That made my night. I won't keep you a minute. As I said, my name is Auntie Maureen Salter, and that's a position of respect with Aboriginal people. I am a Gamilaroi elder, and I am here with you all tonight representing the Gamilaroi people, who are the Aboriginal custodians of this area, to welcome you all to our country. A very warm and special welcome to each and every one of you who have come here tonight for the Starfest celebrations and the Science in the Pub. Winangaya, Ugali. Winangaya means learn. Winangaya means respect. Ugali means celebrate. So learn, respect, and celebrate this special weekend. It's going to be very, very special for all of you. And I would now like to welcome you in the language of my people. Yamanindai, Gia Gaba Gamarai, Walai Baganini. Iladu Maribagiki, Yamadaunga, Nai Murray, Nai Gari, Nai Murray, Gia Gababan Gan, Winangaya Mardi, Daundi, Niningu, Urabala Waladi, Ilambudi, Maramalalaya Nini, Maramala Don, Winangala, Warrambangali, Gaba Bangan. When translated, it goes like this. Welcome everyone. Welcome to Gamilaroi country. It is good that you are here with us. Your time here is special. Welcome to the land of my people. my language, and my people are fantastic. We must remember our people, our land, and identity. We must all share our culture and heritage. Care for each other and care for the land. Be inspired by the beautiful Warrumbungle Mountains. Have a great night.
Thank you, Maureen. Thank you very much. Before I hand over to Robin, there's one more duty I have to perform, which is to let you know that tonight's raffle, to which I'm sure you've all already contributed, is in favour of the Westpac rescue helicopter. That's where the funds will go. The rescue helicopter, I understand, flew over Coonabarabran not very long before the show started, doing a real rescue. I don't know much more about it than that, but it just underlines how important this facility is. So you tonight are supporting the rescue helicopter. If that has inspired you to give yet more money and put more money in your raffle tickets, there'll be another opportunity during the interval. So now, without further ado, it's my pleasure to introduce your host for tonight, Robin Williams, very well known from ABC Radio National. Robin has been a kingpin of Radio National since 1973? Two, there you go. I got it wrong by a year. One of Robin's first tasks as a young presenter-producer was to make a sound documentary about this brand new giant telescope that was being erected on Siding Spring Mountain in the Warrumbungles. And Robin interviewed a lot of people who I remember from that era. It's a delightful documentary. It was rebroadcast in celebration of our 40th anniversary a year or so ago. Robin is so well known, he needs almost no introduction. It is our great pleasure and honour to have him here hosting Science in the Pub once again. Would you please all join me in welcoming Robin Williams?
Thank you. Thank you, Dr. Watson. Rebecca Watson. I worked out why we're here when I was reading The Independent of London. I don't know, you probably can't see this. It says, astrophysics is better than sex. And being a British paper, it must be right, because it says, 7 brief lessons in physics outsold 50 Shades of Grey on publication in Italy last year. In Italy! Can you believe it? No. Exactly. Don't trust the media ever. Well, except when some people from physics and biology are actually in the ABC, as one of our guests tonight on the panel has been. If we go from your left, my right, Dr. Vanessa Moss, who's a postdoctoral researcher at the University of Sydney, working as part of the ARC Centre of Excellence for All-Sky Astrophysics. All-Sky, that's pretty ambitious, isn't it? Test your mic.
Yes, it's a good time to test
That's
the
the
mic.
right answer.
Yes, so all sky. So basically they've claimed to divide the sky up into a few key themes: dark, dynamic, and evolving. And through that we hope to answer some of the biggest questions about the universe.
Thank you. Professor Victoria Meadows, I knew her when she was Vicky Meadows. Was that 20 years ago I interviewed you about peering through the clouds to the surface of Venus?
Quite possibly, yes.
And she was then after the University of Sydney, at Caltech, JPL, and now you're in Seattle in Washington, is that right? That's correct?
University of Washington.
University of Washington, and doing astrobiology as well. And then we have someone I met in company with the Prime Minister. Who was the Prime Minister at the time?
Giving away my age.
No. 6 years ago, it's another 6 Prime Ministers. Professor Naomi McClure-Griffiths, in fact, won the Malcolm McIntosh Prime Minister's Science Prize for her wonderful work in astrophysics.
I did indeed.
Oh!
I failed that test.
And your field?
I have no microphone. I study the Milky Way. I'm a radio astronomer. So these optical images that we've been seeing here, I have no idea what they are.
I met Amanda Bauer more or less for the first time, unless I blinked, last year at Siding Spring Mountain. In fact, my revisit to the dear big dish, as we used to call it when it was going up. In fact, I was doing a documentary about Siding Spring Mountain and the Anglo-Australian telescope long before it was complete, and Charles opened it. And in fact, it got me into trouble because there was a set of engineers there, and they talked about the visit from the British Minister of Science and Education and how they wanted to impress her by building an Aboriginal embassy. And so they borrowed some tarpaulin and they set up this wonderful edifice. But Margaret Thatcher didn't notice. She sailed straight through without necessarily doing the work required. But I got into trouble because they made me cut it out, that part, before it went overseas, because people might have been cross. Amanda, let me explain my reference before to your being with me and the science unit, because we had a scheme to celebrate the 40th anniversary of the science show called 5 Under 40, and out of 500 people in science who are under 40 years of age, Amanda was one of our guests, and you did a fabulous job producing more radio than I've ever seen come out of one amazing fertile brain in 2 weeks, was it?
2 weeks, yeah. It was quite fun. It was a fantastic environment to be around. So many people with those expertise and could do it efficiently. I just had to write the story and they made it come alive. It was great.
We're going to ask a number of longish questions, followed by shortish questions, and then after the break, your turn to ask all sorts of extraordinary questions and see if you can catch them out. See if you can get a good answer from them, or else stump them completely. I'm now going to ask the first longish question, and you just press your button. It'll make a very loud noise. There you are. But use your imagination, as Amanda did when she was with us. The first question: in 2013, the orbiting Cassini spacecraft around Titan spotted a brand new chunk of land that mysteriously appeared out of its second largest sea, Liguria Mare. Shortly thereafter, the magic island disappeared, just as mysteriously into the translucent minus 180 degrees Celsius methane-ethane sea. It then reappeared again, doubling in size from 50 to 100 kilometers. During one of Cassini's recent radar sweeps of Titan, how would you explain the physical process responsible for this sudden appearing landmass? Next question.
Can we put pressure on our planetary scientists?
Read about this. Let's see. The Korean Mare, is it near the pole? Do we know? Am I allowed to
Near
ask
the
questions?
pole?
Yeah. It is near the pole.
Yes. I can see who I'm going to ask the answer to this question. Come on,
I mean,
Dr. Watson. As a certain female politician said, please explain.
Please explain, he said. Yes, I know that lady in question. It's near the pole. So this is one of Titan's... I didn't think I'd have to come up and answer my own questions here. Serves me right, they say. Titan is the most astonishing world in the solar system. It has a surface made of ice. Underneath is an ocean of liquid water. On top, a seas of ethane and methane. And it rains liquid natural gas. But the Guia Mare that Robin mentioned, how did you get to be Neville? Never mind. Neville Williams, you know, he's very big on the science show. That is the second of the largest, second in size, the largest sea on Titan, and it's got this peculiar thing that keeps coming and going. It is thought to be an ethane-methane iceberg that forms and then sinks. But it could just be waves on the surface. Nobody really knows. That's enough from me, folks. Back to Robin Williams.
Well, I think it was Van Daniken. That's where he lives. He goes up and down.
Or the Loch Ness Monster, maybe?
Here's a simpler question. A certain astrophysicist who had been in Cambridge and made some really pulsing discoveries now also mixes her astronomy with poetry related to astrophysics. Can you think of her name?
Jocelyn Bell Burnell?
Ah.
Ding!
Say it more slowly.
Jocelyn Bell Burnell.
And I saw her 2 weeks ago. She's now Professor of Physics, Astrophysics at Oxford. And you may remember that famous, there was a film about it, of her getting these astounding regular beeps and running eventually to the professor, Hewish, was it not, and saying, we think we're getting regular signals. And they kept it quiet for 3 weeks because they thought it was an LGM, which is technical for little green man.
LGM what?
LGM1. And you probably know that there's a famous play on in London called Photograph 51 about the work of Rosalind Franklin, and it stars Nicole Kidman. Well, a similar kind of neglect, except a real neglect, was of Jocelyn Bell, because she surely was likely to get a Nobel Prize for this amazing work. Do you not think, Amanda?
Oh, absolutely. I think it was completely well-deserved by her. But in the end, it was her advisor
Yeah.
who ended up being given the Nobel Prize.
But she's so young.
But she discovered it.
And she did the work.
Yeah, she did all the work. It was her project. In a similar vein, we just found very clear evidence for liquid water on Mars, and it was a PhD student who has done most of the work, who actually has been not given a Nobel Prize just yet, but did a lot of the press that went along with it. So I think in many ways we've gotten a bit better at giving credit to people who deserve it. She was definitely pushed to the side so many years ago and not given the credit for the work she did.
She tells me she doesn't mind because she's dined out on it so often. And she's got a fabulous career. Second question, apart from my little distraction. Astronomy plus quantum physics equals MRI, which saves lives. How do we remind the public and politicians of the value of pure research and how discovery works? Who'd like to dive in there?
Well, I'll dive in. Just having spent 14 years at CSIRO, which has often wheeled out Wi-Fi as a very useful example of something where in radio astronomy they were developing a technique to look for exploding black holes, and lo and behold, something that we all now have in our phones and everywhere throughout our house. I think that's a beautiful example, and it's only one example, and it's always a good idea to remind people of those examples.
Well, you remember Tim Berners-Lee, who was wanting to unite computers in this place called CERN, where they accelerate particles. You know what that led to? The World Wide Web. Eventually, they took notice of him.
I want to add to, when I was doing my thesis work at the Anglo-Australian Observatory, the World Wide Web did not exist, but we had something called ARNet, the Australian American Research Network, and I used that to collaborate with my advisor, who was at JPL at the time, and that eventually became part of the backbone for the World Wide Web. But that was set up for scientists to talk to each other.
The question actually says, how do we remind the public and politicians of the value of this work? So what would you do? Tell them again and again and again, nail them down to the floor and say, do you understand yet?
Yeah, I think it's really important to give specific examples and to remind people that scientists just doing what they love often discover things that are fantastically useful. So just more examples, specific examples.
Well, if I had a mobile phone, which I don't, because I can't stand them. What I say? But pretending that this is a mobile phone, this is my little wallet. And if you imagine that the entrepreneurship, the inventiveness was actually Steve Jobs. In fact, the 7 technologies that make up your iPhone came from publicly funded R&D, most of which was blue sky research. And without that, in fact, Jobs did nothing apart from put it together in a pretty package and sell it. The science, the basis for it, all the 7 technologies came from the kind of research that CSIRO does.
Well, we see that everywhere. I mean, our phone is a good example. We've got GPS on it, and this interacts with satellites that are floating that we have developed the technology to launch. We have this entire network up there, and they send little signals to that, and they can triangulate using general relativity to the meter exactly where you happen to be and how to get to another spot. And if it didn't take into account general relativity, you would be 3 kilometers away minimum from your local pub. So
That's happened to me, actually.
so many things in our daily life these days. We've got our TVs, we've got our phones, we've got the way that we navigate our cars even. Nobody really looks in the back of the phone book anymore to see their maps. They use the computer technology, and so we can't take this stuff for granted. And I think if we can get that appreciation across to kids, how many pieces of technology do they use intuitively that we never experienced as we were growing up? But they're kind of taking for granted what it actually is that goes into that. So if we can get kids to appreciate that, if we can get the general population to appreciate it and speak to their politicians through voting, if there are politicians out there who are very anti-science or just not interested in putting science in education, if we tell them that's not what we want, then that's a good sign as well.
And
Go on.
I was just going to say, it wasn't that long ago that someone was told that playing with electricity wouldn't lead anywhere, or that at the end of I guess it was the 19th century, that everything useful that would be discovered had already been discovered. So.
Indeed. But a figure I rather like, I interviewed Professor Jonathan Haskell from Imperial College in London. And the figure we got was that between 40 and 50% of the wealth of the nation comes from science and technology research. 50, 55, or even 60% comes from R&D that the scientists do. Next question, where in the universe would you most like to visit? Amanda, you've already been there, haven't you? You heard her program. She zoomed in her dreams through the cosmos.
Yeah, I was a science ninja in my dream, and as a science ninja, of course, I don't have to worry about the passage of time or any of those big, large distances. So I zoomed off to the edge of a forming galaxy, and I watched how it went through its different cycles. Of course, I sped up time once I got there. I watched it go through its active black hole phases, and different generations of stars started forming, and then I zoomed down into the black hole because I wanted to feel what its gravity felt like without getting too close, because that might be a bit uncomfortable.
Where would you like to go?
I think the center of the Milky Way. Have you seen those amazing images there where they show all the stars orbiting around the galactic center? And they're just phenomenal. You can Google this, find a movie of this on the web, and the stars that you can see go around the black hole in the galactic center. And it's incredible looking, and you can see it on years, sort of timescales. So because I'm an impatient person, I don't want to wait millennia for answers. I'd like to go to the galactic
Won't
center
you be
and
mashed?
look at heaven. Stretched.
Ah, right. Vicky, where would you like to go?
Well, I'm going to be much closer. So roughly about 8 light years away from us, Kepler statistics tell us that there is a small terrestrial planet orbiting in the habitable zone of a star, an M-dwarf star, a very small one. So I'd like to go there because that planet could maybe have liquid water on its surface and life, but the environment would be very alien to what we're used to. So the star is very red, photosynthesis would be pushed to different wavelengths. Because the star is red and cool, the planet has to be really close to its parent star, and so it's now getting stretched and squished by gravitational forces, as well as getting the radiation from the star, and so it's going to be a very interesting world. So I want to see that one.
By the way, Kepler stopped working, hasn't it? And it's just got stored stuff.
No, Kepler is actually, Kepler has been reborn as K2. So the Kepler mission, so what happened was that the Kepler mission had 3 reaction wheels, which it needed to point at a particular spot in the sky, and it stared at this particular spot in the sky for 4 years running, and was looking for the sort of the periodic dimming of stars because planets were passing in front of them. That's how it discovered planets. But it lost one of its reaction wheels, which meant it couldn't really stabilize itself on the sky. And so the engineers this was brilliant, they very cleverly decided that they would put Kepler down to look in the ecliptic plane, so that's sort of the plane that the planets are in our solar system, because they used the sun's wind, the solar wind, as the third stabilizer. So they have two reaction wheels and the solar wind stabilizing the spacecraft now to stare at fields in the ecliptic plane. And so that's the K2
That
mission.
is incredible.
Pretty clever. Engineers are amazing.
Vanessa, where would you like to go?
So this is even closer to home, actually. So if I could go anywhere, I would go to one of the moons of Saturn, Mimas, which is on one of the really, really close orbits. So if you were standing on the surface of Mimas and you looked out to the horizon where Saturn was, you would probably see it stretching up into the sky. So if you imagine what we see when we go outside and we see our moon in the sky, it would fill one of our horizons. So you could see Saturn on its side and the rings going up right into the sky. And I think that would be a really cool place to go. It's local, so it's maybe doable in the next 50 years. But also just to remind us that the perspective we have here on Earth is a very unique one. So you don't have to go very far before it changes.
Thank you.
Although Mimas looks like the Death Star.
Okay, well that's not why.
It has this massive crater that totally looks like the Death Star.
And then rule the world.
Obviously.
Another question. In your opinion, from the invention of the telescope in 1609 to the Hubble telescope, the square kilometre array, star bugs and so on, what's been the instrument that's seen the greatest astronomical discoveries? Which instrument scored the most, do you think?
Whew, that's a tough one. Tough to narrow that down. Beside the obvious AAT, clearly, I think I'm going to have to go with the Hubble. I mean, there are so many iconic images that we have, and it really, thanks to NASA and its team of kind of press officers and astronomers just getting excited, it produced these images that got the entire public behind it. So when there was a point where the Hubble was not functioning anymore and NASA wasn't going to be able to go and fix it, there was this massive, what do you call it when you sign signatures? Those things.
Petition.
Thank you. There was a massive petition that was spread out online where people really reacted strongly to this because they felt so satisfied by it. And in addition to just capturing the public's attention, when the Hubble first went up, one of the things that they decided to do with it was to look at a region of the sky where, to any other telescope that had existed, this region looked completely empty. And so they pointed the Hubble there for about 1 million seconds, lots of orbits around, and tried to just see what was there. And what they found in this tiny little nothing was 10,000 galaxies, 10,000 little specks of light, every single one of them having about 10 billion stars there, or hundreds of billions of stars. So this was just one of these revolutionary things, almost as much as when the telescope was named after Edwin Hubble, who discovered that there are galaxies outside of the Milky Way. It just stretched our understanding of the universe. This just made it an amazing prospect to be an astronomer because there's no shortage of galaxies out there to study. So I'm in a job for a while.
So Hubble is the obvious choice, and we would all go with that. So I'll shout out for the little guy. So I want to say again a big shout out for Kepler, the little Kepler space mission, which everybody thought it wouldn't work, and it was a very long time to launch. But what Kepler has done with a very simple mechanism, again just staring at the sky, unblinking, and taking all those measurements, is completely revolutionized our idea of how common solar systems like our own are, and just how different extrasolar planets are out there. And I'll point to two discoveries. One is that Kepler found that the most common type of planet in the inner regions of planetary systems are not little terrestrial planets like our own necessarily, but things called sub-Neptunes. These things are smaller than Neptune, but larger than the Earth. And they represent a class of planet that we have no example of in our solar system. You are sitting at the moment on the largest terrestrial planet we have in our solar system. The Earth is it. Okay, but Kepler went out and found that there were zillions of planets much bigger than Earth, but smaller than Neptune. Some of them are fluffy, some of them are solid, so some are super-Earths and some are sub-Neptunes. But we have no idea what these things are, and yet they're very, very common in the universe. And so that was kind of a shock. It was like, hey, we don't have even the most sort of common type of inner planet out there. And the second thing Kepler found was that planetary systems, that found lots of multiple planetary systems, which was interesting. It meant that because of the transiting, it meant that the planets were all together in the sort of same plane. But it found systems where there were 5 planets within the equivalent of the orbit of Mercury. So, of course, Mercury is the innermost planet in our system. It found systems orbiting around stars just like our sun, where there are 5 planets packed in between Mercury and the star. And so these incredibly packed systems are also very common, and that's something, again, we don't have in our own solar system. So the jury's out yet on whether or not we're truly weird, but we're certainly discovering that there's a lot of different types of planetary systems out there, and that's pretty exciting.
Hello. I don't know if me and Naomi would maybe agree on one of the really big telescopes that's made a huge difference, but the early telescopes of Karl Jansky and Grote Reber. So both of these were back in the 1930s and early 1940s. They were looking for radio signals, but they weren't necessarily looking for radio signals from outer space. No one ever expected to see that. So they were detecting signals and starting to realize that they were correlated with the time of the day. So it would change depending on what season it was or where you pointed it. And over time built up this picture that maybe these signals weren't coming from Earth at all. So they had interference from cars, they had things that were coming from Earth, but there was this noise, this static that was not possibly coming from Earth. And this was at a time where people were used to thinking about optical astronomy, they're used to going outside with their eyes, but this was opening a whole new window on the universe. So I think that's been a big change, and radio astronomy has all kind of developed from there.
Yeah, I was gonna pick up on a little tiny little radio telescope, a little feed horn, just a little bitty thing that happened to find the CMB, cosmic microwave background, and looking back to the very beginning of the universe with that, I think is a pretty big discovery. I could be wrong, but I think it was fairly big. And then that was done just with a really tiny little telescope where they thought they had some bird poo on it. Because they couldn't figure out why they were seeing this hiss with this radio telescope, and it turned out that it was actually the beginning of the universe. So,
And you get it on your television, or you used to, didn't you? That
if you have that kind of television now, that's a problem.
Yeah. I have very old-fashioned stuff. Next question: what story, or discovery, or research has gone under the radar this year? In other words, hasn't been given proper attention, that you'd like to pick up and tell us about? One thing that's been found this year.
I can do something. So the reason it's under the radar is because I haven't written the paper yet. But
that doesn't count.
So what my research team, it's called the Virtual Planetary Laboratory, and it uses computer models to simulate extrasolar planets to try and understand what factors in the interaction between a planet and its star allow a planet to have life on it, to be able to support liquid water and to have life on it. And many of you, if you follow this sort of search for life in the universe, you may have heard of the fact that the abundant oxygen in our atmosphere is considered a very obvious, it's still really challenging observation, but it's one of the easiest things you can do is look at our planet and say, wow, abundant oxygen, that couldn't have gotten there without photosynthesis. We don't know of any sort of planetary or geological processes that would have produced that. But my team in the last year has come up with 4 separate ways to make oxygen without life. And so I'm putting together a review paper on this and talking about it, and it's interesting and exciting. Some people think it's depressing. It's like, oh, we thought oxygen was going to be really easy. That's the thing we should go after. But what we're now learning is that there are these other processes, but we're learning the tells. We're learning, if a planetary process is producing oxygen, we know what else to look for that gives away the fact that this oxygen is not due to photosynthesis. So I think that's going to be a really interesting story, and it's certainly very much changing the way we think about how we're going to detect life on other planets.
I have a good supermassive black hole one. So there's been a galaxy in the Virgo cluster, which is relatively close to the Milky Way, that they found 2 supermassive black holes that are orbiting around each other. And when 2 galaxies collide, almost every galaxy has a supermassive black hole in its heart. Eventually, when those galaxies come together, so will those supermassive black holes. But in the grand scheme of the universe, this happens very quickly, so it's not very often that we can capture it and watch it. So these 2 supermassive black holes are very close. They're orbiting around each other. Now, they probably won't coalesce for another 100,000 years or so. So that's still a ways away, but we don't very often get to see the process like this. And it's something that, as we're looking for gravitational waves, because these things in their interaction with each other will produce gravitational waves that we might be able to use as a target as we start to get more sophisticated in our instrumentation to try to detect these, because we still haven't ever detected gravitational waves. So I think that's pretty exciting.
Amanda, is it right if I say gravity waves I'm wrong, unless I'm talking about gravity waves that are holding you to your chair? Gravitational waves are the things that David Blair and others are lying on and trying to look for.
All right, the ones that are traveling through space, yeah.
Right. I just found that out the other day. Any other
I
contributions?
think we actually use gravity waves in meteorology, so phenomenon, atmospheric phenomenon. So that could get confusing. Gravity wave observers.
I don't know if it necessarily went under the radar. It was kind of big, but I guess who here has heard of the plasma tubes that were discovered by a telescope in Western Australia? Okay, Fred. So this is actually my microphone. So this is actually a really great story because it was discovered by an undergraduate student. And so she was using a telescope called the Murchison Wide Field Array to study kind of the effects of the ionosphere. So when we go down to really low frequencies in radio astronomy, down to about 100 megahertz, that kind of area, we start to care about what the atmosphere is doing, but not what it's doing in air particles, but what it's doing in the ionosphere. And so she was studying that and discovered signals that she couldn't explain, and her supervisors couldn't explain as well. And she persisted with this and eventually discovered that there were these kind of signatures were following magnetic field lines of the Earth. So these were these plasma tubes that geophysicists had predicted to exist, but no one had ever found evidence before. And so that was kind of big news, but maybe didn't get as big as it could have been. And so that was really exciting to see that, I guess, if you can persist, if you can look at your data very closely and understand what it's telling you, not necessarily just the astrophysical signals, but what the signals that are affecting, if you have galaxies coming to you, what's happening along the way, and really kind of pursue that and understand that, then you can make really important discoveries along the way. So I think that was really important.
Lovely. We've got 10 minutes for some short questions. And in other words, there is an answer. And I'll whip through them.
We don't do that.
What did India's Chandrayaan-1 satellite confirm the presence of in 2009 and where?
That was a lunar probe or something.
Lunar
wasn't it?
probe.
Yep.
Yes.
Yes.
You got the where.
Mm-hmm.
And what did it find apart from cheese?
Don't
And what
know,
kind of
actually.
cheese?
Oh, different types of cheese. Mm.
Wensleydale.
What did they just find on Mars confirming?
Oh, water.
Water. Indeed. Where is the centre of the universe? How many people know the answer to that in this room? How many people know where the centre of the universe is? Shout.
Everywhere and nowhere.
Everywhere. So you're right. It's here, as well as elsewhere. Excellent. Next question. In 2008, what did the Keck Observatory detect in the infrared orbiting a star called HR 8799, 150 light years from Earth?
3 planets that they
Yes.
imaged. It imaged, you could actually see them as dots.
What were they like, these planets?
They are giant planets. They are observing at the moment with the GPI instrument on the Gemini telescope, and they're getting spectra that make no sense at all. So these are hot, young, Jupiter-like planets, but the spectra, when we tie them with our models, they don't seem to have the right size or mass, or it's a huge mystery. We're having loads of fun.
Isn't it amazing? Because I did a story, was it 20 years ago? Someone who's actually from Melbourne was one of the team who thought he'd found an exoplanet, and they all went public, and then they had to withdraw, and he was mortified. It was a
Pulsar planet? The Pulsar planet?
Pulsar planet.
No,
Yeah.
well, was it a puzzle?
Yes.
Yes.
Yeah.
Right, okay.
And then they found a real one.
And
shortly
then they
after.
found it very quickly afterwards, and
He's
I
done
interviewed
okay
him.
since then, though. He's done okay since then.
Oh, look, he's a hero. I think he's a Swinburne now, is he not?
He is indeed.
That's right. Third question, why do black holes and pulsars emit radiation jets along their poles, and why not the equator?
The magnetic fields don't let the radiation out anywhere else.
These guys are too good. Oh dear. Okay, now here's a shaggy one, a shaggy stellar story. What is the story? Sunburned observers delivered the biggest astronomical punch felt on Earth in a century, 30 times brighter than the sun. Air blast was one for the record books, and the explosion was as powerful as 400,000 tons of TNT. What was it? And if you can pronounce it, you're better than I am.
Is this the asteroid comedy thing over Russia at the time? Who delivered? I forgot. I missed the sunburned observers.
Ah, yeah.
Yes.
Yes.
Meteorite.
The people admitted to hospital with sunburn, weren't there?
Chelyabinsk. Is that
There
how
you
you
go.
pronounce it?
All right.
Meteorite, 15th of February
Russian
2013.
meteorite. Do I get that one? Russian meteorite? No, I had to pronounce it.
It says here, thank you, Fred, on the day of the meteor's arrival, isn't it meteorite?
It was indeed.
Much of the astronomical world's attention was turned towards 2012 DA14, an office building size asteroid that made a close 17,100 mile high, you've got it in kilometers as well, passage over the Earth. News of the Russian meteor took observers by surprise, although experts such as NASA's Bill Cook quickly deduced it was unrelated to 2012 DA14. Amazing story. It still happens. What am I? I was constructed by EOS Australia. You can interrupt, by the way. I will provide a massively detailed record of more than 1 billion stars and galaxies. I contain a $2.5 million camera, which uses 268 million pixels to capture a region of sky 40 times larger than the full moon every 20 seconds.
Sky Mapper.
Yes. Please explain.
So Sky Mapper is this super cute little telescope that's on top of Siding Spring. So if y'all are going to go up there, it kind of looks like an alien, I think. It's got these really cute antenna lightning rods that go off the top. But it's right up at the very top trig point. And so this telescope, it's actually a massive telescope inside of this kind of tiny little dome, and it's robotically operated from Canberra. So it opens up on its own. It's got little weather station up there to tell it when the weather's good, and it's going to look over huge chunks of the sky over and over many times and do a few different projects with that. So what it does is it will look for anything that changes. So if there's a pattern of stars one night and then the next night there happens to be an extra star, something has happened. So maybe a supernova has gone off. That's one thing. And when they look at the same region of sky over and over, you can add up all of those images and you can start to see really faint bits of light over time. So hopefully we'll be able to look at the faint outskirts of galaxies that we can't see when we don't have enough time to just look at them over and over. So it's a very exciting project and it's super cute to see.
Excellent answer. Fabulous. Have an extra prize. Next, what shuttle-like robotic space vehicle has been orbiting the Earth since the 20th of May 2015 it now is, 2015, so a few months. A shuttle-like robotic space vehicle. Aha.
Really?
Would it be
Not
called
heard of the X-37B?
Fred, the X-37B. Oh, of course.
That's a name to conjure with, isn't it?
It's a secret space vessel.
And so we're supposed
It's
to know
a
about the
secret
secret
space
space vessel, are we, Fred?
USA.
I didn't get that memo.
Shoot you.
And it's really there. And it's really empty. No people on it landing.
People, but lots of equipment.
Ah.
High-tech stuff, which we don't know about.
Full of high-tech stuff. There you are, if you can hear at the back.
Speaking of spy technology, I'll just tell a very quick story about how we got our latest. So the next sort of big mission to fly after JWST, the James Webb Space Telescope, which is going to be the supercomputer that, super telescope that will be in the infrared, and it's kind of a successor to Hubble. But beyond that, there's something called WFIRST. And that telescope we acquired because somebody in the U.S. intelligence agency said, hey, go to this warehouse. It's going to be something that you're really going to like. And so they went to the warehouse, and didn't quite happen like that, but it was pretty much close. And there were two basically Hubble-sized telescopes just sitting in there that the surveillance industry hadn't been using. And so they said, here, have these. And so we are going to refurbish one of those and launch it as a cosmological mission that will also have a coronagraph on board. And a coronagraph is something that can block out the light from a parent star so that you can see all the little faint planets around it. And so we'll be doing both cosmology and exoplanet science with this old Spice telescope.
Now this next question is for you. Not you. What Australian spacecraft was launched yesterday, that's Thursday the 1st of October, and where from? NBN. Yes. Excellent. It's called the Malcolm Turnbull, isn't it? Or something like that. Excellent. So you got it right. Where are Norgay Montes? That sounds like a Spanish strip dancer, doesn't it? Norgay Montes.
Pluto?
And her rhythmic guitar. Pardon?
I'm going to guess Pluto.
You're dead right. What are it?
Oh, well. Probably mountains made of nitrogen ice, I think. So we sent the New Horizons spacecraft out past Pluto. It took about 10 years to get there, so longer than some of the lives of the people in here. But it arrived not too long ago, and it did this amazingly close flyby and took a ton of pictures, and it's taken it a long time to actually turn its antennas towards us and send those images back. So we're just now starting to get these incredibly high resolution images of Pluto that we have never seen before. And its features are baffling. There are mountains, there are valleys, there are things that kind of look like maybe they were rivers, there are big flat regions that are smooth, and for some reason they don't have craters, and we have no idea what have wiped out the crater activity. So these, I'm not sure exactly who they're named after, but these are some of the mountains that are made out of this. So there we go.
Excellent.
Yeah.
And talking about Pluto, final question, including Pluto, what is a planet?
Sorry? But Pluto's not a planet.
Pluto's not a planet. I was actually one of the people that signed the petition to have that silly definition that got rid of Pluto revoked, because it was a dynamical argument, and I just don't hold with that. But anyway, so there's two ways of defining a planet. One is based on its intrinsic properties. What's it like? You know, what kind of a world is it? And there's another one where, and this is the one that won out, where you have a dynamical argument that says, okay, if this body has managed to clear its orbit of enough debris, it's considered to be a planet in its own right. But if it's embedded in a whole bunch of other bodies, then it's not really a planet, it's just part of a belt of some sort, Kuiper belt, asteroid belt, whatever.
But it looks like a planet, and it's got
Exactly.
moons.
It looks like a planet, it's round, it has its own self-gravity, it's a round planet. I would call it a planet, but the dynamical argument won out, and because Pluto is one of the larger members, but not the largest member of the Kuiper belt, it lost its planet status. The reason I hate that definition is because I study exoplanets, and if you have to know enough about a planetary system to be able to tell whether the exoplanet you've just discovered has cleared its local neighborhood, then you are never going to be able to define something as a planet. It's a silly, silly definition. And in fact, the way the sorry, I'm getting pretty worked up here. the way the definition was written by the IAU, it even said a body that orbits the sun. And I was like, what? So basically, the definition of a planet didn't take into account all the exoplanets we even knew about at the time. So it was, maybe Pluto doesn't deserve to be a planet. It's not the largest member of the Kuiper belt and so on. But the definition was just silly. And so I signed a petition and said, we need a better definition than that. But
Do you think there will ever be a vote? Will they ever do another definition?
I don't think so. Maybe, but it's a lot of effort, and it was also very silly. And here's another silly thing: it was done by a hand vote in this era of the internet by people who were physically at a meeting. All right, and it was not put out to, let's say, an email vote by a larger fraction of the planetary community. So that was also a bit silly. So maybe one day we'll get an actual sort of email petition vote type thing. But anyway.
Wonderful answer, thank you. And that finishes the first half of the evening. In the second half, we shall have questions from your good selves. And we'll go, is it Fred, to midnight? And beyond. Yeah, midnight tomorrow. So we will have your questions. In the meantime, don't forget there is this wonderful raffle with an extremely worthy cause. So if you turn more attention to it, I'd be extremely grateful. And if you could come back in 25 minutes, which would be something like, say, 20 to 9, if that's okay. Thank you very much. See you next time.